Good afternoon, folks. This is 12B-1 in chemistry. You should also have quiz 12A today. We're going to be discussing measures of concentration today. And as usual, whenever we get into something where we're discussing things like measures of concentration, we probably need to start with some kind of definition so that we understand the term concentration. So, what is concentration? Concentration is the amount of solute that is dissolved in a solvent. The measure of number of solute particles in a certain volume or mass of the solvent. This is a precise quantitative measurement. There are some terms that we commonly use, things like concentrated or dilute. Diluted or concentrated for the purposes of chemistry class are really too vague of terms for us to be able to discuss them. We need to be able to discuss in terms of uh, actual numbers, not qualities, but quantities. And that's really very, very important as we're beginning into this. Any of the measures of concentration that we're going to be discussed are going to follow this general form. The general form is concentration is equal to the amount of solute divided by the amount of solution or the amount of solvent. That's the general form that we're going to be using for all of the different kinds of things that we actually discuss as part of this discussion of concentration whenever we're discussing them. The most common are percent by mass, molarity, and molality, and each one of them has its own advantages and its own unique uses that it has whenever we're discussing it. Amounts may be expressed in grams or moles, and then sometimes we're talking amount of solvent, sometimes we're talking amount of solution, but most of these are pretty common, and you ought to be able to do them pretty easily without too much trouble, I would think. Now let's get into percent by mass. The percent by mass is going to compare the amount of solute to the amount of solution times 100. This is a standard percent calculation. If you think about it in terms of mass, it makes sense that percent by mass would be grams of solute divided by grams of solution, the part over the whole, equals percent over 100. So the percent by mass is going to give you that pretty common use for what we're doing. We normally do things like the salinity of water. So if we're talking the salinity of salt water, ocean water typically has about 3.5 grams of salt in every 100 grams of solution. So you would take 3.5 grams and you would divide it by 100 grams. You'd multiply by 100 and you'd get about a 3.5% solution. We actually don't use this a whole lot in chemistry class. We're not using it a lot in chemistry class because it's really only useful when comparing different concentrations of the same solution and not when you're comparing different types of solutions that's involved. Let's do one. If 5.81 grams of salt is dissolved in water to make 56.3 grams of solution, what's the percent by mass? I'm going to take myself off the screen for just a second. Let me see if I can get myself off the screen for just a second. All right, I'm off the screen. This way you can still hear me, but you can't see me. But I'm also not taking up any spots. So 5.81 grams of solute is divided by the whole, which is 56.3 grams of solution. If I gave you grams of salt and grams of solvent, you'd need to add the two of them together to get grams of solution. So in this case, 5.81 grams of solute divided by 56.3 grams of solution times 100 gives us a 10.3% solution. This is standard. You've been doing these kind of things for a lot of years now. It shouldn't be any difficulty for you to continue to do to do these percent by mass problems at this point in time. Give you a second. If 10 grams of sugar is added to 90 grams of water, what's the percent by mass? Remember that it's part over whole, so sugar is the solute, water is the solvent, but you need the mass of the solution. What's the percent by mass of the solution itself? %. 10 grams of sugar, 90 grams of water. 10 plus 90 is 100. So you're looking for the total. Times 100 gives you a 10% sugar solution. 25 grams of salts dissolved to make 125 grams of solution. What is the percent by mass? Now we've given it to you in 125. So you have the solution itself as well as the solute. So you don't need to add the two of them together to say 125 divided by 150. It's just 25 over 125 times 100. 20%. All right, bring myself back on screen. There I am. Percent by volume is our next methodology. So let's talk percent by volume. Percent by volume is basically the same thing as percent by mass, except instead of masses, we're using... Yeah, I really wish you guys were here to actually answer these questions instead of me answering the way that I am. Volume, that's right. Volume. Percent by volume is actually used on the ingredient labels of lots of household products. When you look at your vinegar, it's going to say it's such and such acetic acid by volume. 10% acetic acid by volume. That's pretty strong vinegar. 5% acetic acid by volume. That means it's got 5 milliliters in every 100 milliliters of solution. So it's the volume of the solute divided by the volume of the solution times 100. Still part over whole equals percent over 100. I mean, it's that exact same concept that you're looking for. When you're looking for the percent, part over whole equals percent over 100, cross multiply and divide. Part times 100 divided by percent, divided by whole gives you the percent if that's what you're actually trying to solve for. This is also not used very often for what we're doing, and since we already did some percent by mass problems and the percent by volume is done exactly the same way as the percent by mass problems, we're going to not do any of percent by volume problems. I'm going to assume you can figure that out on your own. Go watch a Khan Academy video if you can't, or just message me and I'll see what I can do at that point in time. Sorry, my headphones are trying to get pulled off my head. All right, let's move on then. Molarity. Now, this is where it's at. Molarity and molality are going to be the two big things that we do in this class for solution problems, just completely. I mean, you got to be used. You're going to be used to molarity and molality. It's a lot easier than doing the stoichiometry and other things that we've been doing, but molarity and molality. I'm curious how we're going to do organic chem whenever organic chemistry comes along. I haven't figured that out yet. We'll figure it out by the time it comes along. Maybe we'll have to Skype call together and see if we can do it. Kind of like I've discussed doing Quizlet Live with people. I think we can figure out a way to make Quizlet Live work in our own homes if we're interested in doing a Quizlet Live. We have to all be together at a particular time, but I think it's doable if people are interested in it. Obviously not going to require it by any stretch of the imagination, but maybe you're getting bored at the house and you're interested in doing this. While we're at it, let me go ahead and give you this. That way you've got it as we're doing it. So this is the big one. Molarity is the most common expression of concentration in chemistry, and molarity is equal to the moles of the solute divided by the liters of the solution. Moles of solute per liter of solution. So a solution containing 6 moles of hydrochloric acid in a liter of solution would be a 6 molar solution, written as 6 capital M whatever solution. 6 molar hydrochloric acid solution if it was hydrochloric acid. We're going to do a couple of molarity calculations, some sample problems, get you a chance to look at them, and then, like I said, I may send some problems home. Well, I will send some problems home, some assignments home for you to do for molarity and molality whenever the time comes as we're getting into this. But let's look at this first sample problem. If we dissolve 345 grams of hydrochloric acid to make 3.75 liters of solution, this is going to result in what kind of molarity? Now, to start out with, we're already looking at it. It's in grams. For us to do molarity, we need moles of solute and liters of solution. Moles over liters. Moles over liters. We've got the liters, but we don't have the moles. We've got it in grams. So we're going to have to convert 345 grams of hydrochloric acid to moles of hydrochloric acid. Because right now, we only have it in grams of hydrochloric acid. 345 grams of hydrochloric acid, or 3.75 liters of solution. If we use the bridge, the molecular mass of hydrochloric acid is about 36.5 grams per mole. So grams, moles, cancel. This means that we have about 2.52 moles in every 1 liter of solution, or a 2.52 molar hydrochloric acid solution. And that's the way you would say that. 2.52 2 and 5200ths molar hydrochloric acid solution. All right, let me give you a second to work out this problem. If 2.9 moles of sodium chloride is dissolved to make 3.8 liters of solution, what is the molarity? Well, we already got it in moles. We've got the solute in moles. We've got the solution in liters, so it's just 2.9 divided by 3.8, which is about 0.76. 0.76 molar sodium chloride solution. 200 grams of sodium sulfate is added to make 3.5 liters of solution. What is the molarity? Remember, you got to convert those grams to moles before you can do this kind of problem. All right, so what's the molarity of the solution? 4/10 of a gram, 41 hundredths molarity, not gram, mole. 41 hundredths molar solution of sodium sulfate. 200 grams divided by 3.5 liters of solution, but we got to convert the sodium sulfate to moles, so that's about 142 grams per mole. Divide it out, you get 0.40 molar sodium sulfate solution. All right, let's try a third one. You have 6/10 of a liter of half molar hydrochloric acid solution. How many moles does this solution contain? We're going in reverse now. We gave you that it's a half molar solution. We gave you the number of liters. We want to know the number of moles now. Can you work backwards to get there? I can just hear people complaining about having to work backwards right now. Yes, JJ. Yes, Troy. I'm talking to you guys. zero point 0.6 liters of solution. 1 liter of solution is half a mole of hydrochloric acid. That's 0.3 moles of hydrochloric acid. See how that was done? We have 0.6 liters of a half molar solution. So 0.6 liters of a half molar solution gives us 0.3 moles of hydrochloric acid to be able to do that problem. Actually, I think we're going to end with sample problem number 3. I don't want to overload you on this. We will pick up tomorrow on 12B-2, and we'll cover the rest of this. Try to do a few review problems back, and then this will let you do let you finish off molality as well, and we'll discuss molality tomorrow. So I think we're going to cut it off here. My video is going about 17 minutes long. I'm pretty sure I gave you your code at this point in time. If I didn't give you your code, there's your code. We're going to discuss, like I said, we'll do molality. We'll do molality tomorrow. We did molarity today. I'm going to give you some problems to do, and that's going to take a little bit more time. So I don't want you to have a whole lot more to do. I'm going to give you a problem of each different type so that you can actually work on the problems, or a couple of problems of each different type, and that way we'll work it all out. So if you need me, you know where to find me. Feel free to message me. I will be here, and you have 12A due as well, but you're going to have 12. This is 12B-1 we're going to do, and I'm going to give you some problems to do along with it. Thanks. It's been great. If you need me, you know where to find me.